Well, hello everyone. My name is Jonathan, and I'm one of the founders and Chief Product Officer at Voodoo Manufacturing. I'll get a little more into my personal self and the company later on, but I want to start by talking about the ocean tonight. So for those ocean explorers of you, you know that there are a couple ways to go beneath the surface and see what's down there. So one of the main ways you can do this is with scuba diving, right? And if you go scuba diving, typically you'll go down to about 100 feet, maybe 200 feet if you're daring and very good, and you can basically explore that range of the ocean. Now, if you want to go down any deeper than that, really the next option that you have is with a submersible. And to do that, you need to go and rent or buy one. That can be very expensive. And so what happens is people will generally, instead of going to 300 or 400 feet, they'll go right to the bottom. And so as a result of these ways to go and explore what's beneath the ocean, there's actually this phenomena where this middle band between about 200 and 500 feet is less explored than the bands above and below it. And that begs the question of what really is going on in the middle of the ocean. So this might seem a little off topic, but I'll kind of come back to this throughout the presentation. So now to talk a little more about hardware and products. It's getting easier to make things these days, right? Between the tools that we have that are disposable, like Arduino or personal fabrication machines, to the platforms that we have to get funded or make pre-sales, Kickstarter, and Indiegogo. It's really just all around getting easier to go and prototype, build, launch a new product or company. And on the other side of this ecosystem, it's getting much easier as someone looking to buy something or find something to actually go and find that. It's kind of amazing to think that we used to do this with the Sears catalog, right? You used to go and have this big book and flip through the pages to find what you wanted or needed. Whereas today, we have platforms like Amazon, Etsy, Pinterest, right? I mean, you can really find exactly what you want or what you need. And then the things themselves are becoming more niche and more custom in their function and design, right? And this is really happening all across the board, whether it's a bike or a cell phone. So kind of to add on to all of this, right, the time it takes us to now develop and release new products and physical objects is really decreasing very quickly. And that's important because it means new products are coming to market much quicker, they're evolving much quicker, the methods that we take them to market has to speed up. I mean, think of how many cell phones get released every year right now as compared to just a few years ago, right? Way more. And so kind of all these things together are driving us into a direction where it is generally much easier to find exactly what you want for whatever specific application that thing serves you. So the problem here is that manufacturing is divided, right? The way we make things. We have these age-old methods of making things with our hands that are very good at making things that are high quality, very unique or custom, but they don't really scale to high volumes, past a few maybe. And on the other side, we have these innovative manufacturing methods brought to us in the 19th century that brought us the car, right? And these things are very good at going and producing lots of the same thing at very low prices. But there's something kind of missing in the middle here, right? How do we make things in medium volumes that might be unique and custom? And so again, to go back to this ocean analogy, instead of scuba diving, well, we really have hands making things. And instead of submarines, we really have mass manufacturing methods like injection molding or others. And so we kind of have this gap, right, from maybe 1 to 10,000 units, we'll call it, where we don't have a great method of making these physical objects, and therefore it leaves the question of what can you actually make in this range? How would products and the physical things in our lives be different if we could economically make physical objects in this range? So now I'm going to talk about 3D printing, right? This is why you all came here, hopefully this in VR. So 3D printing, you probably know this. It's a new type of, or not new, it's about 30 years old. It's a type of manufacturing method where you are actually adding material together as opposed to maybe cutting it away, like in subtractive manufacturing, or remolding it, like in transformative manufacturing. And 3D printing, there are lots of different types, and all of these different types have their own unique advantages. They have their own high-performance materials that you can print with. Some you can actually print with multiple materials. Some you can print very large objects or very tiny objects, and others you can actually print food and chocolate and even organs. So lots of different types of technologies that make up 3D printing or additive manufacturing as a whole. So 3D printing as a manufacturing method has a few unique advantages over other manufacturing methods. This really comes down to the first being that you can make objects that are custom. With a 3D printer, you basically start with a digital file and you feed that into the printer, and there is no upfront tooling or work that really has to go into getting the printer ready to make that object. And because of that, it is very easy and very cheap to make things that are completely custom or unique, whereas other methods, it's really hard. The second is you can make things that are complex. Now, this is a little debated, basically because complexity is relative, right? You might consider a very sharp corner to be something that's complex. So when I talk about complexity here, I really mean overall geometric complexity, right? If you look at that object to the right, you would typically say that's a complex geometry, and it's actually something that most other manufacturing methods cannot even make. And lastly, we have on-demand, which basically means because there are no upfront costs or tooling required to go and start 3D printing something, you really don't need to hold inventory. There's no cost to changing over from object A to object B, and that kind of plays off the custom point, but it's a little different. So going back to 3D printing as a whole, it's been around for 30 years. Traditionally, it's remained a manufacturing technology that was expensive machines, expensive materials, and therefore it's really remained something that you have to be a professional to go and use. And then, as you all know, in the mid-2000s, the desktop 3D printer arose, right? And this was something that you can now buy for under $5,000. You can go and put it on your desk at home or at work and actually use it to 3D print things. And as a result of the release of the desktop printer, the 3D printing market pretty much soared. So from about 2012 to 2013, just everyone was going gangbusters with 3D printing, imagining all the ways that it's going to change the world. And it was really exciting. And then this happened. Basically, the market crashed, right? And we're now over in 2016. If you ask different people, you might get different answers for why this happened. But I think one of the main reasons it happened is because there was this idea of consumer 3D printing, right? Everyone wanted the 3D printer to be like the desktop computer. The answer is it wasn't. And a lot of that came down to what applications are people using these printers for. But at the end of the day, that image on the top there of a printer at home with a glass of wine next to it and a candle next to it, that wasn't realistic. It was really going to be the professional, maybe the engineer, the artist, designer, in their workspace or maybe in their home who is going to get lots of value out of the desktop 3D printer. But still, the printers were not the problem. These printers were pretty amazing. I mean, you have to really think about what existed before it. You know, the cheapest printer before it on average was probably about $30,000 and went all the way up to $1 million. And so now you have these machines that are maybe a tenth of the cost with much cheaper materials. Their quality that they could produce was really just as high in many cases. And so these were great machines. And in the right scenario, for the right people, they could still add a lot of value. So who are those people? Well, one example is a company called Bot Factory. Bot Factory makes what's called a circuit printer. So that is not actually a 3D printer. It prints conductive pathways that you can make circuits with. So it's a pretty neat machine. This is a startup. They're not selling tens of thousands of units every month. And for them, due to the work it would have required to go and use other more traditional manufacturing methods, the costs and the time required, they figured that it actually made sense to go and use a desktop printer, or a few of them that they owned, to go and produce a handful of the components that went on this machine. So we're talking physical, structural components, brackets and encasings, things like that. And so for them, this was the best option that they could find to make those pieces. But still, well, before that, I mean, one question here is, does this mean, going back to the ocean analogy, that the desktop printer is this thing that can kind of fill that range, right? The parts they were making were unique to their machine. They weren't doing them in super high volumes, so maybe it's a good method. But it's still hard for them to do that, right? They don't really want to have to run printers in their office space. They're not a manufacturing company. They make a product. and it still requires a lot of time, a lot of effort, and these things are not the easiest to run. So to step back for a second, again, hi, I'm Jonathan. I want to provide a little context to kind of let you know about myself and why we're talking about this tonight. So I worked at a company, my company called Layer by Layer, about 4 years ago, and this was at the very beginning of the desktop 3D printer revolution, so to say. We made accessibility software for desktop printers. We basically took designs and pre-compiled them for different desktop printers on our servers, and then allowed you as a consumer or someone with a desktop printer to go and print something out with the click of a button. From there, we actually were acquired by MakerBot, who you all probably know, and went and started working at MakerBot, and one of the main projects we worked on there was software to control large groups of 3D printers. You'll see how that plays in later. And then for MakerBot, I actually worked at a company called Body Labs for a little while. They're a FirstMark company. They're very cool. They make software that lets computers interpret human body shape and pose. That's for another night. But if you kind of add these things up, you'll start to realize that my pathway, at least, has been about mass customization. And it's really led me to Voodoo Manufacturing, where we looked at this machine and we had lots of experience with it. And we asked ourselves, what if you took it and instead of one 3D printer, you made it lots of 3D printers? How would that change the game? And so, thus, Voodoo Manufacturing was born, where we offer fast, affordable, and most importantly, high volume 3D printing as a service. So this is our factory. We're based in East Williamsburg, Brooklyn, and we have an 1,800 square foot space where we have about 125 operational desktop 3D printers. So we call this high volume 3D printing, right? And it's something that hasn't really existed before. But when you take this many 3D printers and you put them in a room together and you hook them together with software, you get a few really unique benefits. So the first, high bandwidth. Basically, we can parallelize any given part that we're printing across these 130 printers. And that would bring the print time per part way down, right? Because if it takes an hour to print something, you can still print that across many machines. These are very low-cost machines with low-cost materials, and so we can pass that on to the customer. We can easily scale when we need to. As a manufacturing company, your demand is not linear, that's for sure. We can produce relatively high quality, as I said before. Even though these machines are low ends, they are still good parts that come off of them. And then reliability is important for us. Even though the machines might not be reliable, as a service, as a factory, we kind of remove that from the equation for our customers, and we make it so whenever they need parts, they get those parts of a predetermined quality. And that's really a key point. So with these printers now, with this factory, I think that we've really filled in this gap here in the ocean or in the manufacturing landscape. Because we can now produce a bunch, 1 to 10,000s, of custom and unique things. And really, you could take that to the extreme and imagine that we don't have to print the same object on all of our printers at the same time. We can print one specific object on each printer at the same time. And that's really what custom means. So to kind of compare some manufacturing methods, injection molding and 3D printing, you can look at scale, cost, and scope, right? And so typically with injection molding, you talk about benefiting from economies of scale. As you increase your scale, then the price per unit goes down. So you're pretty much living in a plane that's independent of scope with injection molding. Yes, you can make another object, but the price of your first object isn't going to benefit from the fact that you're making a second one. With 3D printing, or high volume 3D printing, it's literally just the opposite. There is no such thing as economies of scale in 3D printing. The price per object is going to be flat no matter what volume you produce. But with that said, you can produce any number of objects, and again, that's what custom means, and you will not pay anything more for the fact that you're making more. So again, to bring it home, with high volume 3D printing, you can make unique and custom things economically at high volumes with short lead times. So this is really the cool part that I wanted to spend some time on, is how do we do this, right? It's not trivial to run one desktop printer, and that means it's certainly not trivial to run 130 of them at the same time. So basically, our factory starts with the validation phase. So you'll give us a 3D file, and we'll then go and check it to make sure that it's actually something that's 3D printable. We'll have to repair it sometimes, which for those of you who know about 3D models means we'll have to make it watertight or just make sure that it gets printable. Orientation is a very interesting part. The orientation is literally the way you place the object on the build plate, and a lot of times that affects the print quality very highly. We'll then have to plate things, so for high volume, plating is very important. And that means packing one object onto the build plate as many times as possible. And so for us, this is something that we're working on automating today, and this is what really allows us to scale to super high volumes. And lastly, we go and apply certain machine settings to the file, and that's what we slice it with, where you compile the code that the actual printers run on, and this can greatly affect the finished print quality. So from there, we use software. And again, this is really our secret sauce that allows us to operate at this scale. So our software allows us to take in new jobs or large, high volume orders and basically distribute jobs across our printer fleet. And so we can parallelize as much as we want. We can queue up jobs for the rest of the week. And then you can go and start prints on printers and monitor the statuses. You've got to speed it up a little. And then lastly, at the end of the process, we have to pull things off the build plates, store them, inspect them, which is basically QA, post-process them sometimes, package and ship just as always. So to bring this full circle, I wanted to show you guys some of what's possible and what we've done. We've done all sorts of things. So starting with marketing materials. If you wanted to do something unique that's gonna resonate with your audience, then you could basically create new interactive experiences that really touch home with your brand. So here was a project we did with Autodesk Instructables, where we had their mascot robot that you could go and build at an event. We've worked with content companies delivering memorabilia to their diehard fans, which is something they never would have been able to do except at really high volumes. We work in fashion. We've made entire dresses before, and this is something we're really excited about. Today, some of you may have seen that Under Armour came out with a new 3D printed shoe. Bot Factory, as mentioned before, is one of our favorite customers. We actually produce 7 parts that go on these machines and ship to end customers. And then another great example of the on-demand portion here, a startup called Sensel, which makes basically multi-force touchpad, where you can go and design different overlays for the touchpad depending on what you want to use it for. And so they've actually plugged this app directly into our factory. So every time a new customer designs an overlay, it just gets routed to our factory, we manufacture it, and drop ship it to the customer, and then it's ready for end use with their touchpad. And lastly, we can do post-processing methods where we'll take the object and do something to it like sanding, spray painting, maybe chroming to make it look, feel, or actually behave differently. And so tonight, I want to leave you all with the question of what will you make now knowing that this 1 to 10,000 middle of the ocean range is actually possible for you to dive into, and now you can invent new products, new marketing campaigns in this range with high volume 3D printing. So thanks again. My name's Jonathan. Please feel free to shoot me an email or talk to me after. And we are hiring for any of you who are interested. So again, come and get in touch with me after. Thanks a lot. Bye.
Oh. Yeah, we're just going to do one of them. Actually, since we ran a little bit, I'll do one question that we want.
Cool.
From here. So we actually covered a little bit towards the end, but I guess what gets you excited about 3D printing right now in terms of the main trend? Is that 3D printing metal, 3D printing PCBs? Does it matter? Does it add to what you can do?
Yeah, I mean, I think the most exciting thing is now that we've kind of come down from our high expectation ledge, we're actually thinking about how to take 3D printing and make it useful and valuable, right? And whether that's in medicine, making implants, or printing parts that have electrical components in them, it's really, again, we're out of the daydream and the hype, and now everyone's working to make it valuable.
So it's more about the use case and less about specific technology.
Good question. So Shapeways operates a factory of high-end 3D printers that individually are very expensive and have very expensive materials. And so if you're interested in fancy materials, maybe very high-quality parts, then you should go with Shapeways. But they really can't do high volume, past maybe 20. Their turnaround times are going to be very long, and they're very expensive. And so for us, we're actually enabling companies to think about using us in a more sustainable setting, like making parts that ship to customers.
about cheap, inexpensive machines for high throughput. And kind of like in the future, are you guys thinking about anything in terms of making that scalability by automating things, like removing from the plate? Because I remember attending an event that was Continental like working on like a rolling system so that they can actually continuously print without actually monitoring it. I'm just curious, like what kind of thoughts do you have in terms of making it more scalable?
Absolutely. I mean, our dream is, basically turning this into an Amazon warehouse, right? In Amazon warehouses, how they have the racks move around based on demand. I mean, for us, we see these printers as something that's very modular and scalable. And so whether that's the physical aspect of removing things from the build plates, or some of the things I walked through, where there's actually a significant amount of work that goes into getting a 3D model ready to be printed at high volume. And so we're definitely starting to look into automating, or at least semi-automating everything in that pipeline.
All right, thanks very much.
Thank you.